All right, so this is going to be another video on remainder theorem. It's basically going to be 5 example problems, again, just to further cement this concept of what remainder theorem is all about. All right, so number 11, it says consider the polynomial function p of x right there, and it says verify that p of 9 is equal to 0. If p of 9 is equal to 0, what must one of the factors of p be? All right, so all you really have to do for this one is plug in 9 to that equation. So if you did that for this first part, you'll notice that you do get p of 9 equal to 0. So that means the factor for this one, this is the beauty of remainder theorem, it tells you what the factor is right away, but the factor for this one would be x minus 9. Okay, so one of the factors has to be x minus 9 based on remainder theorem, which is awesome that we know what this factor is right away, because now we can divide out p of x by this factor to find the other two factors, which is what the next part says. For part B, it says find, with a capital I for some reason, the remaining two factors of p. So to find those two other factors, I am actually going to do long division of p of x, and then I'm going to be dividing that by x minus 9. I'm going to use long division to do that. So I'm going to do that right over here. So we have x to the third minus 8x squared minus 29x plus 180. Okay, and we're going to be dividing this by x minus 9. Okay. Now, since we've already went over long division, I'm going to kind of do this a little bit faster. So this is going to be x squared here, and it's going to be x cubed minus 9x squared. Put this in parentheses. We're going to subtract this off. Those leading terms should always cancel. And then you're left with 9x squared minus 8x squared. So that's just going to be 8x squared. Or I'm sorry, just because bleh. So you're going to have negative 8x squared plus 9x squared. Well, that's x squared minus 29x plus 180. Okay, we're going to put an x up here to cancel out that x squared. Put that in parentheses, and then we're subtracting this off here. So that's going to cancel with this. And then you're left with negative 29x plus 180 plus 9x. So it's going to be negative 20x plus 180. We're going to do a minus 20 right here, so then you're going to be left with negative 20x plus 180, and you can see this is going to cancel everything out, and you're going to be left with no remainder, which shows that x minus 9 was a factor. Okay. What's awesome about this, though, too, is that now we have another expression right here, this x squared plus x minus 20. Now essentially that is where our other two solutions are going to be. Our other two factors are going to be in that equation. So what you can do is either use quadratic formula, or you can just factor that out to figure out what those other two factors are. So that's what I'm going to do next here, because the problem says find the remaining two factors of p. Okay, so right now, based on what we have, we know that p of x is equal to x cubed minus 8x squared minus 29x plus 180. And this is going to be equal to x minus 9, that's one of the factors, times x squared plus x minus 20. And the way that I figured this out was by doing long division. Okay, so essentially what I did is if I divided both sides by x minus 9 here, and this as well, doesn't really matter, you'll notice that this and this cancel, so you're left with this part right here. All of this was part of the long division, and we ended up getting this out of it. This actually shows how long division can help create that factored form expression of that p of x. So I'm going to get rid of all this because we don't really care about this so much. But what we do need to find is the linear factors of this part right here. Okay. Well, luckily this actually factors out pretty nicely. Again, you can use quadratic formula too if you want to solve this out. But you're thinking of two numbers that multiply here and add to get this 1, and those two would be x plus 5 and x minus 4. So essentially what the answer for this one would be, it says find the other two factors. The other two factors are what I just found right there. So that would be x plus 5 and x minus 4. So that's basically the answer for part B. There's the answer for part A. Okay. Hopefully you're following along with this. Basically what I did is I divided out that x minus 9, and I got this right here, and then that factors as well. So you end up with finding the other two factors. So you end up with 3 factors overall, the x minus 9, and then these two right here for that p of x. Okay, next it says, state the zeros of p. Well, all you have to do is set each of the factors equal to 0 and solve. Okay, so this means that the factors for p, so this means that the zeros of p would be negative 5, because you would set this equal to 0 and solve, 4, because you would set this equal to 0 and solve, and then as well the x minus 9, if you set that equal to 0 and solve, you would get the third 0, which we should have 3 zeros based on the fundamental theorem of algebra, so it does work out. We found 3 solutions. Okay, this next part, it says sketch the graph of p. I'm actually going to save this for another video, so I'm actually going to get rid of it for right now. So let's ignore that, and then we'll ignore it down here as well. Okay, I'm going to introduce that in a different concept. But for right now, I just really want to focus on remainder theorem, and I don't want to get too off base with this video. All right, the next one, it says consider the polynomial p of x to be this thing. So it's basically the same thing as the last one with different numbers, essentially. It says verify that p of negative 1 is equal to 0. If p of negative 1 is equal to 0, what must the factors be? So it's, again, similar to the last one we did. If p of negative 1 is equal to 0, that means that one of the factors has to be x plus 1. Okay, so state the zeros. We already know that one of them is equal to negative 1, so I'm just going to put that in for part C right there. Now to find the other two factors, we need to use long division, so that's what I'm going to do for part A. I'm going to divide that p of x by x plus 1. I'm going to do 2x cubed plus 3x squared minus 2x minus 3, and we're going to be dividing this all, by x plus 1. Okay, this is going to help us find our other two factors. Okay, there should be 3 linear factors based on that right there. All right, so we're going to have a 2x squared here, and this is going to be 2x cubed plus 2x squared. Parentheses, we're going to subtract this off here. Cancel, cancel, and you're left with x squared minus 2x minus 3. Okay. We're going to multiply this by x here, and you're going to get x squared plus x in parentheses, and then we're subtracting off here. So this is going to be negative, negative. We're going to cancel, cancel, and you're left with negative 3x minus 3, and this will come out nicely because it is a factor. X plus 1 is a factor, so this is going to come out with no remainder, which is exactly what we should see. And everything cancels here, so you're left with no remainder, and you're left with this expression right here. So now what we're going to do is we are going to factor that, or create it in factored form. Now, since I did the other one using factoring, I'm going to actually factor this one by doing quadratic formula, just to kind of show it in a little bit different way. So with quadratic formula, we're going to find these solutions first. So it's going to be x is equal to negative b, which is negative 1, plus or minus the square root of b squared, in this case it's just going to be 1, minus 4ac, which is going to be 4 times 2 times negative 3, which is going to be 24. Negative 24, so that becomes a plus. We're doing the square root of this, and then we're dividing it by 2a, which is 4. Okay, from here, this is the square root of 25, which is just going to be 5. So it's negative 1 minus 5 is negative 6 over 4. And then negative 1 plus 5 is going to be 4 over 4. So your two answers, and this should be negative. I said negative and didn't write it down. And then your two answers should be negative 3/2 and 1 for the solutions. The problem with this, it says what are the factors for it. So I'm going to have to write this in factored form just so to make sure that it matches. So I'm going to rewrite this as x plus 3/2 and x minus 1. Okay, so those are the other two factors here. So So it says find the two other factors. It's going to be x plus 3/2 and x minus 1. Okay. And then from here it says state the zeros. Well, the zeros would be -1, +1, and -3/2. Since I did quadratic formula, I basically already found these solutions for it. Here's the factors. If you remember, all you have to do is find the solutions and then do x minus whatever the solution is. And then here's part A's answer. Okay. Hopefully you're starting to see the beauty of remainder theorem. Remainder theorem allows us to find certain factors, and then those factors we can divide them out using long division to find the other factors. And then we end up having all the factors there. All right, so for 13, it says find the value of k so that this x cubed minus kx squared plus 2 all over x minus 1 has a remainder of 8. So what I'm going to do is write that down here, and I'm going to define this highlighted red part right here as my p. Okay, and if I do p of 1, because technically if you look at this bottom part, it's x minus 1. If you set that equal to 0 and solved, you get 1. So technically p of 1 should be equal to 8. Based on this fact right here, it says the remainder should be 8. So right now I just wrote down remainder theorem. So what I'm going to do here is try to find the value of k by plugging in 1 for the x for p. So it's going to be 1 cubed, so it's 1 to the 3rd power, minus k times 1 squared, plus 2 is equal to 8. Okay, well this is equal to 1, this is equal to 1, so you're going to be left with 3 minus k is equal to 8. I'm going to add 8 to one side, subtract 8 to the other, and you're left with 3 minus 8, which is -5 for your value of k for that one. Okay, now if you did long division and worked that all out and then set the remainder equal to 8 and solved, you would still get k is equal to -5, but as you can see using remainder theorem, it goes a lot faster. Okay, number 14 is a similar style problem where you're trying to solve for k. So what I'm going to do this. So I'm going to do the exact same thing I did before. I'm going to set that numerator equal to p. So this is going to be equal to p. And I'm going to plug in -2, since if I solve that bottom part, x plus 2 is equal to 0, x is equal to -2. So p of -2 is going to be equal to the remainder, which is 16 in this case. So I'm going to plug -2 into the top part, and you're going to be left with -8k minus 2 minus k. From here, you're going to be left with 18, if I add this 2 on both sides, is equal to -9k. And then if you divide both sides by -9, your k value should be equal to -2, and that should be your final answer. Okay. One more problem to go, number 15. It says, show that x to the 151st power is divisible by x minus 1. Okay, well, let's just say that this is equal to p. Just to make it easier, I don't want to have to rewrite this. So I'm going to say this is equal to p. All we need to do is find out what p of 1 is, because if I set this equal to 0 and solve, it'd be x equals 1. So if you plug 1 into this, you should get 0 if x minus 1 is divisible. Because if it's divisible, that means it's a factor, and we're just basically using remainder theorem. So you would be left with 1 to the 151st power, which is just 1, minus 21 times 1, plus 20. Okay, well, 21 minus -21 and 20 are going to be -1. This is really just 1 minus 1, which is 0, and that basically shows right there the fact that p of 1 is equal to 0. This basically shows that x minus 1 is divisible, that x minus 1 is a factor of that x to the 151st power minus 21x plus 20. Now, if you wanted, you can do long division. It would take you a long time to do that because you're dividing by x minus 1 so many times because it's x to the 151st power. But you can kind of see the shortcut by doing remainder theorem, just plugging in the 1 and seeing that p of 1 is equal to 0. It shows that x minus 1 is a factor. So that's basically remainder theorem taught using 5 example problems. If you have any questions about anything in this video, let me know.